Yeah, welcome and thanks for the introduction. Actually, I'm presenting the work that is done here at Utrecht University at the Department of Physical Geography, and already since 30 years now, more or less. And basically, overcoupling is the work on PCRaster. So I will shortly outline what PCRaster is, basically the spatial temporal modeling idea performed with PCRaster. I will give a brief introduction of a few of applications or models that are built with PCRaster, and I will give outlook on the research projects that we are currently doing. And well, actually, the basic idea or issue of the modeling cycle is that you have a very broad range from domain scientists, which are really thinking in processes or mathematical equations, and on the other range, you have basically the software engineers, which are kind of able to implement all kinds of different models. But yeah, the problem is that you have this broad range. There's quite a huge knowledge gap that needs to be bridged. So one of the design considerations was at early times of PCRaster that domain specialists should be able to perform the modeling cycle. They should be able to describe the models in a language they understand. And there needs to be a software tool that provides building blocks to construct these kind of dynamic models. And this is basically the idea. We have a set of function. You have raster-based data sets with operations on it, which are then used to construct models. And well, the idea wasn't entirely new at that time. You had some kind of map algebra operations, so you could static analysis on data sets. With the invention that PCRaster brought, that it was introducing the capability to model over time. So you could express your processes that should be executed on every time step, and a modeling framework would such execute this model such that you can model over a particular time span. And this is actually done on field-based models, which you can see here. Um, the basic concept now of PCRaster is that we have a Python module or Python package which provides all kinds of raster-based operations. So you see a few examples here. Well, it's mainly a lot of operations which are tailored to hydrology. So you have particular flow operations. So you can see here on the top, you have some kind of local drainage network, and you have particular operations that operate on these data sets. You can calculate accumulated flow or transported material on these data sets. Well, you have point operations, you have area operations, and you have focal operations. So an entire set of operations which the modeler can use to construct models. And by using Python as a modeling language, we provide a very straightforward syntax and tool for the model construction. Well, actually, all the functions are executed itself in C++, so that we still maintain the performance of the operations. But the construction language is used in Python and very friendly for domain scientists. We are not only able to construct dynamic models, but we are also able to construct models that can run in a Monte Carlo simulation. So we have a particular modeling framework which provides template classes and framework classes for this. So basically, it's very straightforward to execute the Monte Carlo simulations and to analyze the results afterwards. And we're not only using Monte Carlo filtering, but we're also using data assimilation. So in our framework, you can use the particle filter or the ensemble Kalman filter, which basically means that you run ensemble, you update the model states when you have observations, and then you continue the model runs. And well, here very small, you can see for each run different realizations and the model results, which are then basically different and you can use for uncertainty estimation, for example. So basically, what PCRaster is, well, it's a set of special operations which are accessible in Python. We have a modeling framework which allows for uncertainty analysis. We provide some interaction with NumPy and GDAL, so it's very feasible for developing or to convert your data sets or to read your data sets from other formats. We have visualization tools. So, well, the spatial temporal and uncertain data is very straightforwardly visualized over time for the spatial data sets. And, well, the entire package is installable now in a rather straightforward way for 3 operating systems and different Python versions. So if you want to have some information, well, you can use it. It's free of charge. We have courses, and you can have information on the links of the website that are given here. So that's basically the software package that we provide, the building blocks that modeler, domain scientists can use it, and that mainly it's in the domain of hydrology. So hydrologists, but also ecologists, or all kinds of other domains which have some kind of a raster-based background, can use PCRaster for constructing the models. And some application examples I will give now. And we have the PCRaster global water balance model, which is actually developed here at the Department of Physical Geography by Mark Meekens, Ransom Beek, and quite some other people. It's a global hydrological and resources model, which is now more globally working on 5 minutes, so roughly 10 kilometers on a daily time step. For particular regions, you have also a finer resolution. So the image already gives well an impression. I'm not going to outline what exactly all processes are involved in the model, but there are quite some processes. So we have groundwater processes, we have surface processes, you have different demands are involved. So there's quite some interaction implemented in the model. If you're really interested to it, well, it's an open source version, and you can find at least the source code of the model on GitHub. Just to give an impression of the output for PCRaster, you can see on the left there's a discharge map, also on 10 kilometer resolution, so already relatively fine resolution on a global scale, and also the evapotranspiration map just as an output example for the capability of that model. Another application is on the PCRaster land use change model, which is, well, what the name already says, really land use change model. So its main purpose is to assess the most suitable sites of particular land uses, and it was especially used in the setting of bioenergy plants. And the question is, well, where do we plant these bioenergy crops, and what are the effects for this, for example? So that's one of the applications which is Pulik doing. And also the model, if you are interested in, the model code is on GitHub, and it's developed by GitHub Versteken. And an example for Brazil, for example, is the model estimating what are the probabilities of particular land uses, so that one raster cell is assigned this particular land use. That's what you see on the left-hand side, and on the right-hand side, the model also includes the indirect changes. So if you allocate particular land use type on a particular reason, most likely there's, for some other reason, some influence, so the indirect land use change associated with it. So this is also modeled in this model, So you can have direct and indirect light exchange effects to be analyzed. A project that we are performing ourselves that's actually concerning the human health, and we are modeling environmental impacts on human health, and in this case especially air pollution. So we have air pollution models for different pollutants, so NO2 or NOx or a particular matter of different sizes. And basically we do it for the Netherlands or some other areas in Europe and partly on a global scale, where we model these on a very, or at least for the Netherlands, for a very high resolution. So we have nationwide Dutch maps for different air pollutants. On the left-hand side, you can see here the PM10 concentration. And what we can do with these maps actually, you can see on the right-hand side, we can use travel routes and combine this with air pollution concentrations to calculate the exposure to particular pollutants when you travel through the city. So we have here two examples. In the beginning, you follow the same route more or less, and in the end, well, you have some kind of different routes, and you immediately see that they also have a different exposure according to the route you took. So basically, this can lead, for example, to give route recommendations on the healthiest route. So that's another application that that we are working on. And for example, what we now actually working on research projects, I will briefly touch upon now.
3 minutes.
And well, it's basically that we have a look on the combination of field-based and agent-based model, which is now actually quite a desired problem that we want to combine both phenomena in one model. So you have, for example, the digital elevation map or moving animals. So how do we approach this? Actually, we developed one data model which is capable to store both phenomena, such that we can store and access field-based and agent-based, point-based, to name it shortly, in one data model. So we have well, the different hierarchical structure to set it up, and we implement this, the data model named Louis, in an HDF format, which is an open format. And well, we also, next to the data format, we work on parallel algorithms because, well, computing this kind of models is getting more intensive. So we're looking in the context of Louis with that as well. This is partly related rather C++ level. So we also building on a Campo modeling framework, which is a Python-based data structure for field and agents, which provides input and outputs to the Louis database and operations on the field and agents. And actually, the analogy that we want to take is to bring the map algebra concept to the agent-based modeling world. And this is how it looks. For example, it's a Python script. So you have a very clean syntax of phenomena, property sets, properties, which you can modify. We have sets on functions which on
1 minute.
Work on objects, which are food store locations. You see the red dots in this case. And we have the corresponding field agents, which is actually the surrounding of the corresponding food stores. So this is actually in our current development modeling language, what we are busy with. So this just gives a very brief overview. If you are interested in our new modeling language or environmental field agent-based modeling, we have a workshop on Friday at 11 o'clock. And if you're interested in more on the Louis and high performance computing aspects that you're working on, there's a presentation tomorrow by Derek Kassenberg. And well, that's for me for the moment. if you have any questions, I'm happy to answer them.
Thank you very much. Maybe a round of applause. I mean, it's difficult. I don't know how to work online, but thank you very much for your presentation. I would like to invite now the audience to ask questions. If you have any question, please raise your hand in the chat or type your question in the chat. We have a few minutes. Okay, I think the presentation was very clear. I don't see any questions at the moment. Maybe I can ask a few just out of curiosity. So I'm personally a user, or I've been a user of PCRaster. So I was just wondering how is it the community around PCRaster going? If it's, do you have indications? Do you monitor that? Is it growing? Is it, because I think the development is mainly led by Utrecht, but then the user community is more international. Do you have a view on that? Do you have a view of that?
Well, the main development work is indeed done by us here in Utrecht. So regarding code contributions, it's well concentrated on our group. It's rather difficult to say what or how large the user page is, because for some time the package was free for download and we had no idea how many people were using it. We know, well, it's used all over the world. There are some research institutes which are using it, JRC or ECMWF or some other groups. And now, at least from the Conda package that we have, we get some kind of a download estimates again, which give us a rough estimation of yeah, how many users there will be. But there's no clear number of really users. So we have some questions on the mailing list, but it's not an extremely high frequency. So yeah, it's a tricky question, to answer. Well, it is still used. We see new publication popping up which refer to PCRaster, but yeah, I can't give a number of users. So